Hello students. Today I shall talk about simple harmonic motion, damped harmonic motion, and also the forced harmonic motions. First of all, I should explain the simple harmonic motion, then I should explain the damped harmonic motions and what can be the equations of damped harmonic motions, and forced harmonic motions. So what can be the equation that is suited for forced harmonic vibrations? Now, as the very name suggests, the simple harmonic motion, it means it's a very simple motion, as the very name suggests, and the motion must be in a harmonic manner, and of course the motion should be there. Motion means it must be in a moving position, it must not in a static position. So the word simple, it comes before harmonic. Now the word harmonic actually means that the motion has got a periodic manner in the sense that a particular position within its the way in which it is moving, the path in which it is moving. So the particular object which is moving, it is crossing a particular point after a certain period of time, after a certain fixed period of time, and then this motion is called periodic motion. So it is maintaining a period basically. After a certain amount of time, after a certain time, it is again coming to that point. So that's why this is called periodic motions. Periodic motions, it is going in this way, it is coming again in this way, again it is going back in this way. So if you consider a particular point, so you can see that a particular point is crossing, a particular point is being crossed by this object after a certain particular amount of time. So this is a harmonic motion. This is called harmonic motion. Now a simple harmonic motion. Simple harmonic motion, what does it mean? The simple harmonic motion, it means there must be a relation of this motion with the displacement, because the acceleration, in case of simple harmonic motion, the acceleration is proportional to displacement. This is simple. Acceleration is proportional to displacement. The motion must be harmonic. If the harmonic motion is bounded by the equations, with the equation in which the acceleration is proportional to displacement, then this is a simple harmonic motion. So you can see here, acceleration, mass into acceleration is the force. Mass into acceleration is the force. So accelerations in the calculus notations, we can say like this, that this is d2x dt square. If x is the displacement, then d2x dt square is the acceleration. Now m into d2x dt square is nothing but the force, mass into acceleration. According to Newton's second law, it is force. Now m into dtx dt square, that is proportional to displacement x with a negative sign, minus, because when it is accelerated, means the acceleration is a direction in which it is increasing, the displacement is decreasing. Suppose it is here. Now the acceleration, if you go in these directions, it is going upwards. It means if it is going upwards, then you see that displacement, actually displacement is taking from the mean position. Mean position means this is, suppose, from these the displacement is taking. Now displacement when increasing, the acceleration is decreasing. Now when it is coming downwards, so very well you can see that, very well you can tell also that when it is going downwards here in these positions, the acceleration should be highest, and when it is going upward, the acceleration should be lowest here, and then again it will come, the acceleration will be highest here. So acceleration should be highest at the position x is equal to 0, because x is measured from this position. Now it is going upward, x is increasing, acceleration is decreasing. So since the acceleration, increment of acceleration is associated with the decrement of the displacement, so here a negative sign appears. Now m into dt x dt square is equal to minus sx. S is one is constant, steepness constant. So m d2 x dt square is equal to m d2 x dt square is equal to minus sx. This is an equation for a simple harmonic motion. Now, whenever there is any motion, any simple harmonic motion, so there is always a hindrance, there is always an obstacle. See, maybe comes from the particle collisions of the air. Suppose it is going in this direction, some air particles are there and it is going through the air. So the particles of the air has got some obstacle, and that's why after a certain time, it will go like this, and after a certain time it will stop. Why it will stop? Because of the fact that the motion become damped, it becomes damped. So damped harmonic motions, and you can see that the motion which is damped, if the velocity is higher, then there will be more obstacle from the air particle, more collisions will be there. So if the velocity is lower, it is going very, very slow, then the less collisions from the air particles. Suppose I am taking into consideration the air particles only. There are other kinds of obstacle may be there. So you can see the motion is basically proportional to the velocity. If the velocity is higher, then it will be more damped. If the velocity is lower, then it will be less damped. So the velocity factor dx dt comes here. So it is proportional to the velocity. So the main damped factor is k into dx dt. And k into dx dt is again the negative sign should be there. Because here again, when the velocity is higher, the collisions will be higher and the motion will be more and more damped. So the displacement will be lesser. So again, you can see that m d2 x dt square is equal to minus of sx minus of k into dx dt. This is the equations for damped harmonic vibration.